All right, this is more vertical circles practice. So you have a 48 kilogram child. The tricky part here is that there's two chains. So you have two inward forces of 350 newtons. The radius of the circle is 3 meters. What seems a little bit goofy is when you swing, you're just going back and forth. You're not completing the circle, but you're still going in a circle because that 3 meters is constant, right? So you're still covering an arc of a circle. So hopefully that makes sense. And again, you have two of these, 350 newtons. I calculated the weight for you because you all know how to do that. And the center of the circle is the branch. So we have the sum of the forces equals mv squared over r. We have two 350 newtons pulling in. The earth is pulling down, which in this case is out. So negative equals m, which is 48. V squared over the radius of the circle is 3 meters. Okay, that turns into 700 minus 470.4 equals 16 V squared. Let's see what that is. To 29.6 equals 16 V squared. Divide both sides by 16. You get V squared equals 14.35. Take the square root of both sides and you get 3.79 meters per second. Okay, again, so the tricky part here was that there were two ropes pulling in and the weight going out, and that the radius, the length of these chains was the radius of the circle. Okay, now we're going to do more roller coasters. So question A is at the bottom of the coaster, and you have a speed of 20, and the radius is 10. And what else do you know? The mass of the coaster is 500. So the track is pushing, which is in, and the earth is pulling down. So you have sum of the forces equals mv squared over r. You have the normal minus the weight. And that's we want the normal. Let's see, the weight is 500 times 9.8, which is 4,900. So we have normal minus 4,900 equals 500 times 20 squared over 10. So normal minus 4,900 equals 20,000. I'm going to add 4,900 to both sides. So the normal equals 24,900 newtons. Okay, that's why those tracks are steel, right? There's a lot of stress on those roller coaster tracks to turn things. Okay, and then question B is, what is the maximum speed the vehicle can have at point B and still remain on the track? So this is good because the other flying off, losing contact, was at the top, and this is flying off at the bottom. Okay, so what do we have? The radius is 15. The person is attracted to the earth with the weight, and tracks push. So the normal would be down. And we have sum of the forces equals mv squared over r. Remaining on the track means the normal is 0, or like it's about to go to 0. So we're going to set that equal to 0 and figure out how fast we, like at the speed we're solving for, the normal will be 0 for a split second, but because the person has velocity, then they'll literally drive themselves into the track and the normal will not be 0. So that is the slowest I can go. If I go slower than that, then the weight is more than you need, and I'm going to pull, the weight's going to be enough to pull you in. You're not flying off tangent fast enough, so and the weight will pull you in, and which means pull you away from the track. Okay, so we're going to find what happened. We're going to find how fast do I need to go for the normal to be 0 for a split second. And if I go slower than that, it's going to happen sooner rather than just for a split second at the top. Okay, so the mass does cancel, but they did give it to you. So I think it's 500. So we're going to say 500 times 9.8 equals 500. V squared over R is 15. So 4,900 equals 50 divided by, 500 equals 33.3, repeating V squared. So divide both sides by 33.3 repeating, and you get V squared equals 147, and then you take the square root of both sides, and you get V equals 12.12 meters per second. So make sure you understand this conceptually. With a speed of 12.12, the normal will be 0 for a split second, but then because the speed isn't 0, the rider will slam themselves into the track. If they go faster than that, if they're going, let's say 15 meters per second, then the weight isn't enough to turn them, and you need some normal. So the faster they go, the greater that normal force will be. Because the weight is fixed, and think about the hover disc demo, the faster you go, the more you have to push in, and if the weight's not enough, then the normal needs to pick up the slack. All right, that is the end of vertical circles, and I will see you in class.